Okay, now I'm going to show you how you can do a half-life measurement with the gamma ray spectroscope. So what we've been seeing so far is histograms of the energies of the gamma rays that come out. What we can also do is we can say, for this time, all your gamma rays, all your pulses, I count them and dump them into this channel. Then this channel, then this channel. And we can say how long you have to wait. So we can say, spend a second and tell me the counts you got, the number of gamma rays you got in this second, then in this second, then in this second. It stands to reason if you're using up all your radioactive atoms, that will be a graph that's decreasing in time. Well, we can do that. We have a neutron howitzer in there. We have a couple little pellets of plutonium, and we can do a thing called neutron activation. So we've got some indium foil. We activated the indium foil and now made it a little bit radioactive. So we're going to put the indium foil in here, and just to show you it's radioactive, I'm going to show you the spectrum of it. Here's the spectrum of it. It's not terribly radioactive. Obviously, it's not. Nothing here is terribly radioactive. It's all safe to handle. But if we go to the linear plot, we see peaks. This is a very interesting spectrum, actually. We already see peaks. We don't want to deal with this. What we're going to do is something different. We're not doing spectroscopy. We're doing the activity. We're doing the half-life measurement. So let's go to a different mode. The mode we're going to now is MCS, multi-channel scaling, internal. There you go. Now we're going to do settings. We're going to go down to the MCS settings, and we're going to say the dwell time. We've got 4,000 channels. How many seconds do we need, or how long do we need to spend counting gamma rays in each channel? So if this is 200 milliseconds, it means put into each channel consecutive 200 millisecond intervals of time. Let's not do that. Let's do 400 milliseconds. Okay, that's nearly half a second. So now we've got 20 minutes of data. Actually, that's not enough for this. What you'll need, I know from experience, what you'll need is about 40 minutes of data. So you'll have to double that, maybe put in 800 milliseconds, but it doesn't matter. Now go, let's see what happens. If we come over here, where are we? Here we're seeing, as on the horizontal axis down here, it's slowly creeping across, and we're seeing I'll hit the log graph. Look, we're seeing the number of gamma rays that come out every 400 milliseconds. Now, if we waited here long enough, this would be a negative exponential decay. And from that data, you can save this in the pull-down file menus. You can get the half-life of it. It's very cool. We can also get the half-life of very short-lived samples, but you would have to fiddle around and play with it and see what's giving you some good data. There's something else you can do. By counting the number of gamma rays that come every second, you can see the absolute activity of a sample. You can tell me how many gamma rays are coming out of a sample. That's another experiment you can do. There's a wide range of experiments you can do, and this will give you a list to choose from.